What's up guys, this is Massey. Welcome to my channel. This video I want to give an example regarding Coulomb's law. This is the application of Coulomb's law and we need to find out the electrical force. 3 microcoulomb charge is placed at the origin and a negative 4 microcoulomb charge is placed 2 meters to the right. What is the force on the first charge due to the presence of the second charge, and what is the force on the second charge due to the presence of the first one? So the first thing I need to do, I will have the x and y axis. So here we have the positive charge, which is 3 microcoulomb, and here I have the negative charge. If we assume we have 2 meters is the distance between these two, Q1 is 3 microcoulomb and Q2 is negative 4 microcoulomb. So in order to find the electric force, we need to use the electrical force equation, which is F equals to, or Fe equals to K times Q1 Q2 divided by R squared. So if I want to show you the electric force, Q1, particle 1 affects on the Q2, and since there are unlike charges, attract this one, so that's gonna be F2, and it is a vector, and this charge, this particle is gonna affect on this first one, and we pull it pulls the first one and it attracts to each other. So we need to find out F1 and F2. So F1 will be K times Q1 Q2 divided by R squared, which will be, K is Coulomb's constant, which is 9 times 10 to the power of 9 Newton meter squared per Coulomb squared. Q1 is 3 times 10 to the power of negative 6, is 10 to the power of negative 6 because we have microcoulomb. So 10 to the power of negative 6 Coulomb. And then we have the second one is 4 times 10 to the power of negative 6 Coulomb divided by 2 meters squared. So the answer will be 2 to the power of 2 is 4, they cancel out, 9 times 3 is going to be 27, so the answer will be 2.7 times 10 to the power of negative 2, or you can say 0.027 Newton. That's going to be F1. Now let's find out F2. F2 is going to be same thing, K Q1 Q2 divided by R squared. And we will have exactly the same thing because Q1 and Q2 it's not gonna change, K is not gonna change, and the distance is not gonna change as well. So it's gonna be 0.027, and this is gonna be the magnitude. But since it's going to the left hand side, to the negative side, it's gonna be negative 0.027 Newton, or 2.7 times 10 to the power of negative 2 Newton. So this one is going to be, this example is the one of the simplest example in finding electrical force and using the Coulomb's law. I hope you enjoyed this video. Please leave me a comment if you have any question and I get back to you as soon as possible. If you found this video useful, please like it. You can also subscribe to this channel to have access to many other videos regarding math, chemistry, and physics. Thank you for watching and have a great day.